Welcome students. In this lecture series, we'll try to understand integral calculus. Integral calculus. The first topic of this integral calculus is indefinite integration. Indefinite integration. So let us first start with the understanding of indefinite integration. What is indefinite integration? So indefinite integration is just the inverse process of differentiation. So indefinite integration is the inverse process of differentiation. So we have already understood what differentiation is and how we differentiate functions. So if you have a function f of x, so if d by dx of f of x is the function g of x, if the differentiation of the function f of x is g of x, then we write integration of g of x dx. So this dx is sent onto this side. This implies d of f of x is equal to g of x dx, and we apply integral symbol on both sides. This is a new symbol that you are going to encounter in this chapter. This is a symbol for indefinite integration. This is a symbol for indefinite integration. So integration of df of x is equal to integration of g of x dx, and this d and this integral symbol effectively gets cancelled because we have defined indefinite integration as the inverse of differentiation. So integration of g of x dx can be written as f of x. So if d by dx of f of x is g of x, then integration of g of x dx is f of x. So the definition is clear, right? Indefinite integration is the inverse of differentiation. Now, there is a slight problem in this process. So why is this called indefinite integration? This word indefinite is very important. So why is it called indefinite integration? Because, so let us take an example. So d by dx of sin x, so we know that it is equal to cos x. So d by dx of sin x is equal to cos x. So from the definition that we have written, it implies that integration of cos x dx, integration of cos x dx is equal to sin x. But this is not it. There is some complication in this process. It is, if you take d by dx of sin x plus any constant c, so you can put any constant here, that is sin x plus 1 or sin x plus 2, sin x plus 3, anything. So what is the differentiation of sin x plus c? It is also equal to cos x, right? Because we know that the differentiation of constant is 0. So sin x plus any constant is equal to cos x. This implies integration of cos x dx now is sin x plus c. So c is any constant. So c can be any constant. So as you can see, integration of cos x dx is not just equal to sin x. It can be equal to sin x plus any constant c. So the answer for integration, indefinite integration of cos x dx is not unique. So the integration for the indefinite integration of cos x dx can be equal to sin x or sin x plus 1, sin x plus 2, sin x plus 0.5, anything, sin x plus any arbitrary constant. So indefinite integration of a function is not unique. That is why this is called indefinite integral. That is, the answer for this integration is not definite. You won't get a unique answer for this process. So indefinite integration of cos x dx from now on is not just sin x, so it is equal to sin x plus any arbitrary constant. And similarly, if you do the same process here, if d of f of x by dx is equal to g of x, d of f of x plus any constant with respect to dx is also equal to g of x. So indefinite integration of g of x dx is equal to f of x plus an arbitrary constant c. So where c is an arbitrary constant. So this is the important thing that you need to remember in the definition of indefinite integration. So when you integrate any function dx, you get the function fx plus an arbitrary constant c. So integration of sin x, integration of cos x dx is equal to sin x plus some arbitrary constant. So this is the meaning of indefinite integration. So indefinite integration can be thought of as the inverse process of differentiation, and when you integrate any function indefinitely, that is, if you do indefinite integration of any function, you get the function f plus an arbitrary constant c. So now let us look at some standard integration formulas which can be derived from the differentiation formulas. So first, d by dx of x power n by n plus 1. So as we know, d by dx of x power n plus 1 is n plus 1 x power n. This n plus 1 and this n plus 1 gets cancelled. So d by dx of x power n plus 1 by n plus 1 is x power n. So integration of x power n dx will be equal to x power n plus 1 by n plus 1. Integration of x to the power n dx is equal to x power n plus 1 by n plus 1 plus c. And d by dx of log mod x is nothing but 1 by x. So integration of 1 by x dx will be equal to log mod x plus c. So you will be wondering why I have written log mod x, because you know that d by dx of log x is also equal to 1 by x. So if I write d by dx of log x, that will be valid only for positive x. So but this formula is valid for all x. So d by dx of log mod x is always equal to 1 by x. So integration of 1 by x dx will always be equal to log mod x plus c. And d by dx of e power x is again e power x. So integration of e power x dx is e power x. D by dx of a power x by log a is a power x. So integration of a power x dx is a power x by log a plus c. And differentiation of sin x is cos x. So integration of cos x is sin x plus c. And differentiation of minus cos x is plus sin x. So integration of sin x becomes minus cos x plus c. So now let's look at the further formulas. Next, we know that d by dx of tan x is secant square x. So integration of secant square x dx is tan x plus c. Integration of minus cot x is cosecant square. So integration of cosecant square x dx is minus cot x plus c. Differentiation of secant x is secant x tan x. So integration of secant x tan x is secant x plus c. Integration of minus cosecant x is cosecant x cot x. So integration of cosecant x cot x is integration of cosecant x cot x is minus cosecant x plus c. And differentiation of sin inverse x is 1 by root 1 minus x square. So integration of 1 by root 1 minus x square dx is sin inverse x plus c. Differentiation of tan inverse x is 1 by 1 plus x square. So integration of 1 by 1 plus x square dx is tan inverse x plus c. Differentiation of secant inverse x is 1 by x root x square minus 1. So integration of 1 by x root x square minus 1 dx is secant inverse x plus c. So these are the standard integration formulas from which you can start your study. So let us first do some examples of questions using the standard integration formula before we go forward. And before plunging into questions, let us look at the basic algebra of integration. So you have integration of f1 of x plus f2 of x whole dx. You have a sum of two functions inside integration. You can always write it as integration of f1 of x dx plus integration of f2 of x dx. So we have a sum or difference of two standard functions. So integration of f1 plus or minus f2 of x dx can be written as integration of the first function dx plus minus integration of the second function dx. And integration of k times f of x dx. Whenever the function f of x is being multiplied by a constant inside integration, this constant can be brought out of the integration. That is, this becomes k times integration of f of x dx. K times integration of fx dx. So these are the two basic formulas that you can use to simplify the bigger limits into bigger integrations into smaller integrations.